Good day, everyone. I am Nia Jane S. Lara from BIS IT Food Technology 36, and for today, I am going to tackle about Chapter 9 Management of Quality. So, I will just discuss my assigned topic, which are quality certification, quality and the supply chain, total quality management, problem solving and process improvement, quality tools, and cooperation strategy. So for the objectives are discuss the importance of ethics in managing quality, compare inequality awards, discuss our quality certification and its importance, describe TQM or total quality management, give an overview of problem solving, give an overview of process improvement. So, for Chapter 6, Quality Certification is a generic phrase that refers to the two basic concepts certifying an individual's knowledge and certifying an organization's quality management system. The significance of quality certification is acknowledged by many companies who conduct business abroad. So, through a number of standards and guidelines, the International Organization for Standardization or ISO supports global norms for enhancement of quality, productivity, and operational efficiency. The standards offer the significant economic and social benefits and are utilized by commercial and industrial companies, regulatory bodies, governments, and trade groups. The standard have huge role in society as a whole, in addition to being extremely significant for designers, manufacturers, suppliers, service providers, and customers. So there are three types of ISO standards: the 9000 standard, 14,000, and 24,700 standards. So ISO 9000 and ISO 14000 are two of the best known of them because concerning quality management, ISO 9000 exists. It covers the steps a business takes to guarantee that its goods or service meet the needs of its clients. The ISO 14000 standard focuses on what a company does to reduce the damage that its operations do to the environment. Both ISO 9000 and 14000 emphasize ongoing improvement and are related to an organization's processes rather than its goods and service. Furthermore, the standards are intended to be universal regardless of the organization's line of business. The system must incorporate the fundamental components found in ISO 9000 or ISO 14000 in order to be considered a valid quality management system or environmental management system. So the reason why both ISO 9000 and ISO 14000 is important in a company because it improves production efficiency, contribute to good relations with regulatory agencies and the public, and it satisfies customers' needs. The ISO 9000 guidelines are essential for businesses doing business on a global scale, especially in Europe. They must go through a program that includes on-site evaluation and documenting quality practices. Frequently, the procedure takes 12 to 18 months. With certification comes inclusion in an ISO database, which suppliers looking for recognized business can use as a resource. They typically have the upper hand over unregistered businesses. More than 40,000 corporations that are registered worldwide are found in Europe. The foundation of the most recent edition of ISO 9000 is comprised of 8 quality management principles. First is a customer focus, second, leadership, 3, involvement of people, 4, a process approach, 5th, a system approach to management, 6th, continual improvement, 7, used a factual approach to decision making, and lastly is mutually beneficial supplier relationship. So there are also 3 major areas of standard for ISO 14000. First is management system. Management system is a system developed and integration of the environmental responsibilities into business planning. Second is operation, a consumption of natural resources and energy. And the last one is environmental systems, measuring, assessing, and managing emotion, effluents, and other waste streams. The quality of and effectiveness of office equipment with recycled parts are covered by ISO 24700. The ISO 24700 standard specifies product characteristics for use in an original equipment. Manufacturers or authorized third-party declaration of conformity to show that a market product that uses recycled components performs equally well to new, meeting equivalent to new component specifications and performance criteria, and continuing to meet all safety and environmental standards required by responsibly built products. It applies to market goods whose production and recovery procedures lead to reuse of elements. So the ISO 24700 is where the government requires a natural benchmark to evaluate the quality, safety, and performance of equipment that contains reused components and to demonstrate the environmental responsibility of the supplier. Let's go to chapter 9.7, which is quality and supply chain. So, business executives are becoming more aware of how crucial their chains are to reaching their quality objectives. Measuring consumers' impressions of quality, identifying issue areas, and fixing those problems are necessary for success. Companies encounter a broad variety in the sophistication of quality assurance when dealing with supplier quality in global supply chains. Some less developed nations may have little to no awareness of contemporary quality techniques, despite the fact that richer countries frequently have good level of sophistication. This raises significant legal concerns for businesses who outsource to those regions. Supply chain quality management increasingly places a focus on lowering outsourcing risk as well as product or service variation and overhead. Risk arises from the use of inferior tools or working practices, which may result in subpar goods and possible product responsibility. These hazards can be decreased by tighter vendor management and employee training. Processes that are not under control cause variation, which can be decreased by sophisticated quality control. So, in improving quality and reducing risk in offshoring, the chairman, president, and CEO of Arrow Electronics, William E. Mitchell, provide 10 recommendations for lowering product quality and associated risk in an offshore supply chain. The recommendations were ostensibly made for electronic suppliers, but they provide a solid place to start for many businesses trying to lower risk and potential qualities issue. So the first is source from reputable, well-established companies with tight internal controls. So the second is before doing business with supply chain partners, thoroughly investigate their backgrounds, checking trade references and previous company history. 3 is implement site inspections of supply partners and find out what systems have been put in place to track quality. 4 is conduct continual evaluations of supply chain partners' performance and maintain regular contact with them in order to compare their performance to predetermined benchmark and develop improvement strategies. 5th is only source from companies that are willing to provide a guarantee for products in writing. 6. To reduce the danger of purchasing a fake product, be conscious with dealing with businesses that do not have franchise connection with distribution partners. 8 is in a supply chain partner's operations, look for the International Organization for Standardization or ISO or other comparable internationally acknowledged certifications. 9. Establish relationship with third-party organizations. 10. Transform a quality into quantifiable, well-defined goals with supply chain associates and see to it that these KPIs are shared routinely with staff. Those are some guidelines that will help a company in preventing scams and fraud. Let's go to chapter 9.8, Total Quality Management. Total Quality Management, or TQM, is a phrase used to describe an organization's pursuit of quality. This strategy is based on three main principles. First is a never-ending push to improve, which is referred to as continuous improvement. Second is the involvement of everyone in the organization. Third is a goal of customer satisfaction, which means meeting or exceeding customer expectation. We can describe the TQM approach as follows. First, find out the public desires. This can entail incorporating customer input into decision making through the use of surveys, focus groups, interviews, or another method. Second, create a product or service that will satisfy clients' expectation. Make it simple to manufacture and simple to use. Third, create procedures that make it easier to complete a task currently for the first time. Find the areas where errors are most likely to happen and work to prevent them. Find out why mistakes happen when they do so that they are less likely to happen again. Fourth, keep track of results and use them to guide improvement in the system. Never stop trying to improve. Fifth, extend those concepts throughout the supply chain. The last one is top management must be involved and committed, otherwise, total quality management just be another fad that fails and fades away. So, total quality management initiatives have been effectively implemented by numerous businesses. TQM initiatives are developed by the commitment and teamwork of everyone inside the firm. The explanation that comes before gives a good sense of TQM. Although it doesn't cover everything, a few other crucial TQM components include continuous improvement, the philosophy that seeks to improve all factors related to the process of converting inputs into outputs on an ongoing basis is called continuous improvement. Second is competitive benchmark. This involves identifying other organizations that are the best at something and studying on how they do it to learn how to improve your operation. Third, employee empowerment. Giving workers the responsibility for improvements and the authority to make change to accomplish them provides strong motivation for employees. Fourth, team approach. The use of teams for problem solving and to achieve consensus takes advantage of group synergy, gets people involved, and promotes a spirit of cooperation and shared values among employees. Fifth, decision based on facts rather than opinion. Management gathers and analyzes data as a basis for decision making. 6. Knowledge of tools. Employees and managers are trained in the use of quality tools. 7. Supplier quality. Suppliers must be included in quality assurance and quality improvements efforts so that their processes are capable of delivering quality parts and materials in a timely manner. 8. Champion. A TQM champion's job is to promote the value and importance of TQM principles throughout the company. 9. Quality at the source. Refers to the philosophy of making each worker responsible for the quality of his or her work. The idea is to do it right the first time. Suppliers are partners in the process, and long-term relationship are encouraged. This gives suppliers a vital stake in providing quality goods and services. It would be incorrect to think of TQM as merely a collection of techniques rather than TQM reflects a whole new attitude toward quality. It is about the culture of an organization. To thoroughly reap the benefits of TQM, the organization must change its culture. Are the obstacles to implementing TQM. So the first obstacle is lack of company-wide definition of quality. Efforts aren't coordinated. People are working at cross purposes, addressing different issues and using different measures of success. 2. Lack of strategic plan for change. Without such a plan, the change of success is lessened and the need to address strategic implications of change is ignored. Third, lack of customer focus. Without a customer focus, there is a risk of customers' dissatisfactions. 4. Poor interorganizational communication. The left hand doesn't know what the right hand is doing. Frustration, waste, and confusion ensue. Fifth, lack of employee empowerment. Not empowering employees gives the impression of not trusting employees to fix problems. Add red tapes and delay solutions. 6. View of quality as quick fix. Quality needs to be a long-term, continuing effort. 7. Emphasis on short-term financial result. For example, duct tape solution often threats symptoms, spend a little now, a lot more time later. 8. Inordinate presence of internal politics and turf issues. This can sap the energy of an organization and derail the best of ideas. 9. Lack of strong motivation. Managers needs to make sure employees are motivated. 10. Lack of time to devote the quality initiatives. Don't add more work without adding additional resources. 11. Lack of leaderships. Managers need to be a leader. So if there is obstacle, there is also criticism of TQM. First is advocates may pursue TQM programs blindly, focusing attention on quality even though other priorities may be more important. For example, responding quickly to a competitor's advances. 2. Programs may not be linked to the strategies of organization in a meaningful way. Third, quality-related decision may not be tied to market performance. For instance, customer satisfaction may be emphasized to the extent that its cost far exceeds any direct or indirect benefit of doing so. 4. Failure to carefully plan a program before embarking on it can lead to false starts, employee confusion, and meaningless results. 5th, organizations sometimes pursue continuous improvement. Example, incremental improvement when dramatic improvement is needed. 6. Quality efforts may not be tied to results. Chapter 9.9 Problem Solving and Process Improvement. Problem solving is one of the basic procedure of TQM. In order to be successful, problem solving efforts should follow a standard approach. So in problem solving and process improvement, there is the thing so-called the plan, do, study, act cycle. So the plan, do, study, act cycle, also referred to as either the Shehart cycle or the Deming wheel, is the conceptual basis for problem solving activities. So these are the 4 basic steps in the cycle. First is a plan. Plan begin by studying the current process, document the process, then collect data on the process or problem. Second is do. Do implement the plan on a small scale if possible. Document any changes made during this phase, called data systematically for evaluation. Third is study. Study, evaluate the data collection during the do phase. Check how closely the results match the original goals of the plan phase. Last is act. Act if the results are successful. Standardize the new method and communicate the new method to all people associated with process. So this is table 9.7, basic steps in problem solving. So employing this sequence of steps provides a systematic approach to continuous improvement. First is step 1, define the problem and establish an improvement goal. Give problem definition carefully consideration. Don't rush through these steps because this will serve as the focal point of problem solving effort. Step 2. Develop performance measure and collect data. The solution must be based on facts. Possible tools include check sheet, scatter diagram, histogram, run chart, and control chart. Step 3. Analyze the problem. Possible tools include Pareto chart, cause and effect diagram. Step 4. Generate potential solution. Methods include brainstorming, interviewing, and surveying. Step 5. Choose a solution. Identify the criteria for choosing a solution. Apply criteria to potential solution and select the best one. 6. Implement the solution. Keep everyone informed. Step 7. Monitor the solution to see if it accomplishes the goal. If not, modify the solution or return to step 1. Possible tools include control chart and run chart. So this is the example of plan, do, study, act. So picture A is the PDSA cycle and the picture B is the PDSA cycle that is applied to problem solving. Process improvement, a systematic approach to improving process. It involves documentation, measurement, and analysis for the purpose of improving the functioning of the process. Typically, goals of process improvement include increasing customer satisfaction, achieving higher quality, reducing waste, reducing costs, increasing productivity, and reducing processing time. So, Table 9.8 is the overview of process improvement. A. Map the process. Collect information about process. Identify each step in process for each step. Determine the inputs and outputs, the people involved, the decisions that are made. Document such measure as time, cost, space, waste, employee morale, and any employee turnover, accidents or safety hazards, working condition, revenues, or profits. Quality and satisfaction as appropriate. B. Analyze the process. Ask the question about the process. Is the flow logical? Are any steps or activities missing? Are there any duplication? 2. Ask this question about each step. Does the step add value? Does any waste occur at this step? Could the time be shortened? Could the cost to perform the step be reduced? Could 2 or more steps be combined? C. Redesign the process. Using the result of the analysis, redesign the process. Determine the improvements. Potential measures include reduction in time, cost, space, waste, employee turnover, accidents, safety hazard, and increases improvements in employee morale, working conditions, revenues or profits, quality, and customer satisfaction. Six Sigma is a word with many interpretations according to statistics. Six Sigma refers to a process, product, or service having no more than 3.4 defects per million opportunities. Conceptually, the phrase refers to a program created the likelihood of errors in order to minimize cost and increase customer satisfaction. So, these are the guiding principles of Six Sigma. First, reduction of variation is an important goal. 2. The methodology is data-driven. It requires valid measurements. 3. Outputs are determined by inputs. Focus on modifying and controlling inputs to improve outputs. 4. Only a critical few inputs have significant impact on outputs. Concentrate on those. DMAIC, or Define, Measure, Analyze, Improve, Control, is a formalized problem-solving process of Six Sigma. It is composed of 5 steps that can be applied to any process to improve its effectiveness. So the steps are: first, define. Set the context and objectives for improvement. 2. Measure. Determine the baseline performance and capability of the process. Third, analyze. Use data and tools to understand the cause and effect relationship of the process. Fourth, improve. Develop the modifications that lead to a validated improvement in the process. Fifth, control. Establish plan and procedures to ensure the improvement are sustained. So, chapter 9.10, quality tools. There are a number of tools that an organization can use for problem solving and process improvement. This section describes 8 of these tools. The tools aid in data collection and interpretation and provide a basis for decision making. The first 7 tools are often referred to as the 7 basic quality tools. First is flowchart, second is check sheets, third is histogram, fourth is Pareto analysis, fifth is scatter diagrams, sixth is control chart, and 7 is cause and effect diagram. So a flow chart is a visual representation of a process. As a problem-solving tool, a flow chart can help investigators in identifying possible points in a process where problem occur. So these are the picture of flow chart. Flow chart is also a diagram of step in a process. Check sheets. A check sheet is a simple tool frequently used for problem identification. Check sheets provide a format that enables users to record and organize data in a way that facilitates collections and analysis. So, check sheets, a tool for organizing and collecting data, a tally of problems or other events by category. Histograms. A histogram can be useful in getting a sense of distribution of observed values. So, a histogram is a chart that shows an empirical frequency distribution. Scatter diagrams. A scatter diagram can be useful in deciding if there is a correct correlation between the values of the variables. A graph that shows the degree and direction of relationship between two variables. Pareto analysis. Pareto analysis is a technique for focusing attention on the most important problem areas. The Pareto concept, named after the 19th century Italian economist Vilfredo Pareto, is that relatively few factors generally account for a large percentage of the total cases. A diagram that arranges categories from highest to lowest frequency of occurrence. A control chart can be used to monitor a process to see if the process output is random. A statistical chart of time-related ordered values for sample statistic. Sample is sample means. Quality circles. One way companies have tapped employees for ideas concerning quality improvement is through quality circles. The circles comprise a number of workers who get together periodically to discuss ways of improving products and processes. A diagram used to organize a search for the cause of a problem and also known as a fishbone diagram. A run chart. A run chart can be used to track the values of a variables over time. Tool for tracking results over a period of time. So these are some illustration of the use of graphical tools. This section presents some illustration of the use of graphical tools in process of product improvement. So figure 9.12 is the employing graphical tools in problem solving. And figure 9.13 is a comparison of before and after using Pareto charts. Figure 9.4 is using a control chart to track improvements. Methods for generating ideas. Brainstorming is a technique in which a group of people share thoughts and ideas on problems in a relaxed atmosphere that encourages unrestrained collective thinking. Quality circles. One way companies have top employees for ideas concerning quality improvements is through quality circles. The circles comprise a number of workers who get together periodically to discuss ways of improving products and processes. Benchmarking is an approach that can inject new energy into improvements efforts. The benchmarking process usually involves these steps. First is identify a critical process that needs improvement. Example, order in entry, distribution, or service after sale. 2. Identify an organization that exists in the process, preferably the best. 3. Control the benchmark organization. Visit it and study the benchmark activity. 4. Analyze the data. 5th, improve the critical process of own organization. Insight in what rivals are doing can be gained by choosing an industry leader. But rivals may be reluctant to offer this knowledge. In order to address this issue, a number of businesses are conducting benchmarking studies and sharing their findings with other organizations while keeping the source of the data a secret. Chapter 9.11 Operation Strategy. An operation strategy is a set of decisions an organization makes regarding the production and delivery of its goods. An organization operation strategy works in tandem with its overall business strategy, helping the organization to achieve its long-term goals and improvement competitiveness in the marketplace. For example, a company that produces and sells computers may have the following operation: obtaining materials, working with suppliers, designing new computers, manufacturing computer designs, managing employees, delivering finished computers to sellers or consumers. So there is a key success factors for operation strategies. First is goal. You can establish a goal for every operation to give the operation direction and may help you with decision regarding the operation, which may help achieve the larger goals of the organization. 2 is employees. Most operations have employees who perform them. Having the right employees for each task can improve the quality of the finished task. Innovation. Innovation can help organizations find better ways to operate and potentially gain an advantage over their competitors. Analysis. All operations require regular analysis, and with analysis you can learn which operations are running well and which need improvement. So let's go to chapter 10, quality control. So the chapter outline of chapter 10 is process capability, which include capability analysis, improving process capability, Taguchi loss function, limitation of capability, and operation strategy. Learning objectives. Explain how control charts are used to monitor a process and the concept that underlie their use. Use and interpret control chart. Chapter 10.4 Process Capability. Process capability is defined as statistical measure of the inherent process variability of a given characteristic. You can use a process capability study to assess the ability of a process to meet specification. Specification or tolerances are established by engineering design or customer requirements. They indicate a range of values in which individual units of output must fall in order to be acceptable. Control limits are statistical limits that reflect the extent to which sample statistics such as means and ranges can vary due to the randomness alone. Process variability reflects the natural of inherent variability in a process. It is measured in terms of the process standard deviation. Capability analysis. Capability analysis is performed on a process that is controlled. Example, the process inhibits only random variation. For the purpose of determining if the range of variation is within design specification that would make the output acceptable for its extended use. If it is within the specification, the process is said to be capable. If it's not, the manager must decide how to correct the situation. So this is some example, figure 10.15, process capability and specification may or may not match. A manager has the option of using any one of three machines for a job. The processes and their standard deviations are listed below. Determine which machines are capable in the specification of 10.00 mm and 10.80 mm. So the table shows the process A, B, C, its standard deviation. And the table 2 is process standard deviations with process with. To assess the capability of a machine or process, a capability index can be computed using the formula below. Process capability equal specification width over process width was upper specification minus lower specification. 6 of the process equals 11 minus 10 over 6 times 10. So it is equal to 1.67. So let's go to another equation. So if a process is not centered, a slightly different measure is used to compute its capability. This index is represented by the symbol CPK. It is computed by finding the difference between each of the specification limits and the mean, identifying the smaller difference, and dividing the difference by 3 standard deviations of the process. The CPK is equal to smaller of upper specification minus process mean over 3 process mean minus lower specification over 3. A process has a mean of 9.20 grams and a standard deviation of 0.30 gram. The lower specification limit is 7.50 grams and the upper specification limit is 10.50 grams. Compute CPK. So first is compute the index of the lower specification. So process mean minus lower specification over 3. So the process mean is 9.20 and minus the lower specification, which is 7.50 over 3, then or 0.30. It is equals to 1.70 over 0.90 and the answer is 1.89. And the other computation is to compute the index for the upper specification. Upper specification over process mean over 3. 10.50 minus 9.20 over 0.90 equals 1.30 over 0.90 and the answer is 1.44. Improving process capability. Improving process capability requires changing the process target value and reducing the process variability that is inherent in a process. This might involve simplifying, standardizing, making the process mistake-proof, upgrading equipment, automating. So this example of table 10.5 for example. Table 10.5 process capability method. Simplify, eliminate steps, reduce the number of parts, use modular design. Standardize, use standard parts, standard procedures. Make mistake-proof, design parts that can only be assembled the correct way. Have simple checks to verify a procedure has been performed correctly. Upgrade equipment, replace worn-out equipment. Take advantage of technological improvements. Automate, substitute automated process for manual processing. So, Taguchi loss function, based on my research, is pronounced as Nuki Taguchi, a Japanese equality expert, holds a non-traditional view of what constitutes poor quality, and hence the cost of poor quality. Limitation of capability indexes. There are several risks of using a capability index. First, the process may not be stable, in which case of capability index is meaningless. 2. The process output may not be normally distributed, in which case inferences about the fraction of output that isn't acceptable will be incorrect. Third is the process is not centered, but the capability index is used giving a misleading result. Let's go to chapter 10.5, Operation Strategy. Since almost all clients give quality and significant amount of thought, reaching and sustaining quality standards is crucial for all commercial operations. Designing products and services and ensuring quality are two essential steps in the process. Operation strategy is only one part of overall business or corporate strategy, but is crucial for competitiveness and success. Without a strong operations strategy, companies fail to keep up with changing markets and lose out to more strategic competitors. Many companies, big and small, have struggled with operations strategy, often lacking in comparison with technologically savvy competitors. The role and purpose of operation strategy. It is to give the operations function a strategy so that it can allocate its resources as efficiently as possible. The organization's policies and goals for using its resources to support its long-term and competitive strategy are outlined in the operation strategy. So that would be all chapter 9 and 10, and thank you for listening.